Okay, so today we are going to look at section 8-5, which is using the law of signs. Now we've been using sine, cosine, and tangent to find missing parts of right triangles, but sometimes we need to find missing parts of non-right triangles. So you can use trig functions to solve problems that involve triangles that are not right triangles. And the law of signs says I'll draw a picture of this in a minute, but it says let triangle ABC be any, emphasis on any, meaning it doesn't have to be right, be any triangle with lowercase a, lowercase b, and lowercase c representing the measures of sides opposite angles with measures capital A, capital B, and capital C, respectively. So side lengths on our triangles are going to be represented with lowercase letters, whereas angle measures are going to be represented with capital letters. And so our triangle might look like this. I'm going to draw a non-right triangle. So it could be acute, it could be obtuse, just not right. Because if it's right, we would just use normal sine, cosine, tangent. So let's make this A, B, and C. So those are all capital letters. So opposite angle A would be side A, which is little a. Opposite angle B would be side B, which is little b. Opposite angle C is side C, which is little c. Same A's, B's, and C's that we use on a right triangle with Pythagorean theorem, but you cannot use Pythagorean theorem with a non-right triangle. So you have a triangle, it's not right, it has the following, then you could possibly use the law of signs to solve it. So we would do, law of signs says you can take the sine of angle A and divide it by the measure of side A. You can set that equal to the sine of angle B divided by the measure of side B. Or you can set that equal to the sine of angle C divided by the measure of side C. All you need is 2 of these 3 ratios to set equal to each other to make a true proportion. And you could flip the sine of A and the side measure, you could flip those so long as you flip the other ratio as well. Alright, so one more thing, we got to talk about the different cases at which you might have law of signs. So write the following down. Finding the measures of all the angles and sides of a triangle is called solving the triangle. So if you're asked to solve the triangle, they're asking you to find the measures of all 6, 3 angles, and 3 sides. The law of sines can be used to solve a triangle in the following cases. So there are 2 cases where we might use the law of sines. So case 1, so one reason might be you know the measures of 2 angles and any side of a triangle. So you know 2 of the 3 angles and any one of the sides. Because remember, if you know 2 of the 3 angles, then you can find the 3rd angle by using that sum angle theorem, adding them together, subtracting them from 180. And then we'll use the law of sines to find the missing other 2 sides. So then there's case 2. You know the measures of 2 sides and an angle opposite one of these sides. Or one of the sides of the triangle. Really, one of the 2 sides that you know of that triangle. So in other words, if these are the 2 sides that you know of your triangle, you want the angle that would be opposite those 2 sides. You do not want that included angle. If you have that included angle in those 2 sides, you would be using the law of cosines, which we will learn next. Okay, so let's look at an example of case 1. So I can turn it so it's not quite so crooked. There. So example 1. You are to solve triangle x, y, z if the measure of angle z is equal to 39, and that's assumed that that's in degrees. The measure of angle y is equal to 88, again in degrees, and lowercase y is equal to 70. So lowercase y implies that you are given a side length of the triangle. And I have 2 angles and a side length, so that would be case 1. And you may or may not be given the triangle. If you're not given a picture of the triangle, then you just draw one. And you just kind of guess as to where the angles might be. X, Y, and Z. So I've named my angles with capital letters, and I'm going to put in here what they gave me. They gave me that angle Z is 39 degrees. Angle Y is 88 degrees. And the measure of side Y, which would be across from angle Y, is 70. So that means that across from angle X, this would be side X. And across from angle Z, this would be side Z. And of course, we don't know angle X. So we're going to set very specific steps. The easiest thing for you to find right now would be the measure of angle X, because you know these two angles. So we're going to use the sum angle theorem to find the measure of angle X. So I have 180 degrees minus the sum of those two, 88 degrees plus 39 degrees equals my handy dandy calculator, 180 minus 88 plus 39, 53 degrees. So I know that the measure of angle X is equal to 53 degrees. So there's one down, two to go. So I'm going to put 53 degrees in my picture so I can use it appropriately later. Then step 2, I've got to find one of my sides. I would suggest finding the side across from your largest angle first. Our largest angle is 88 degrees. We already know that side. So my next largest angle is 53 degrees. So let's find the measure of side X. So step 2, find the measure of side X using your law of sines proportion. So you've got to use the angle and the side opposite of each other, because that's going to give us a full ratio. So I know this angle and I know the side opposite it. So that gives me one full ratio, so I have to use those. So I'm going to take the sine of angle Y and divide it by the measure of side Y. And I'm going to set that equal to, if I want to find X, 53 degrees is across from X, so I have to use that angle and the side opposite it. So I'm going to find the sine of angle X and divide that by side X. So then plug in your information. Sine of Y is 88 degrees, we'll find that in a minute, divided by the measure of side Y is 70, equals, we're going to find, oh, we already know X. Oopsies. We know that X is 53 degrees, so we'll find that in a minute, divided by what we don't know is side X. So, whoops, you can't see that. So that's what we're going to solve for next. We have a proportion, so we're going to cross multiply and solve. So I have X times the sine of 88 degrees equals 70 times the sine of 53 degrees. I would not replace sine of 88 and sine of 53 degrees with their decimal equivalencies yet until you solve for X. To solve for X, we need to undo what's happening here. So we're going to divide both sides by sine of 88. And so I get X is equal to 70 times, we're going to use our table of values or your calculator. Most of you will be using your table of values, and we're going to find the sine of 53 degrees. So 53, sine column, we're looking at 7986. So 0.7986 divided by, now find the sine of 88 degrees. So here's 88. Sine is 0.9994. So 0.9994. So the rest is done in your calc. So I have 70 times 0.7986 equals, divided by 0.9994 equals. If I were you, I would probably round to 1 or 2 decimal places, so I'm going to round to 2. So I've got X is approximately equal to 55.94, And I want to make sure that I know whether this is in degrees or units. They didn't give me any measurements like inches or feet, and since I know I'm finding a side length, this has to be in units. I don't know what the units are, but I'm going to put X for units. So there's 2 down, 1 to go. So step 3. The last thing that we have to find, though, and let's put what we just found, 55.94 units up in our picture. So there it is. The last thing we have to find is side Z, which is across from angle Z. So I have to use that in a ratio. I'm still going to use sine of y over side y because that's my full ratio. I don't want to use this ratio that I just came up with because if I made a mistake in my calculations here, then I definitely will have a mistake here if I try to use what I came up with. So I'm going to continue to use what I was given because I know that there's no mistake there, along with angle Z and side Z. So find the measure of side Z using. So we are going to do sine of y divided by measure of side y equals, I want side Z, so I want sine of Z divided by the measure of side Z. So replace what you know. Sine of y is 88 degrees divided by side y has a measure of 7 units equals sine of angle Z is 39 degrees divided by, and we are trying to find the measure of side Z. It's a proportion, so we're going to cross multiply and solve. So Z times sine of 88 degrees equals 70 times sine of 39 degrees. Got to solve for Z, so undo what's happening to it by dividing by the sine of 88 degrees to both sides. And I get Z is equal to 70 times, I've got to look up the sine of 39 degrees. So here's 39, and then sine is 0.6293. Divided by, and then the sine of 88 is what we used before, so divide by 0.9994. So on the calculator, I've got 70 times 0.6293 gives me that, divided by 0.9994 gives me that. So I've got Z is approximately equal to, we're going to round to 2 decimal places, 44.08, and again Z is in units because it is a side length. And then we are going to replace in our picture our 44.08 units. So you've just solved a triangle because now you know all 6 pieces. So let's look at one more example. Like this, we're going to look at example 2. So for example 2, you have a triangular brace, has one side, meters long, the angle opposite the 9-meter side measures 70 degrees and the measure of angle C is equal to 31 degrees. what is the height of the brace? So this one would be really handy to have a picture with. Fortunately, you would be given a picture with this particular problem. So here's what the brace looks like. So this is your triangle ABC, and then this would be the height of the brace, so that's your H. And so I'm going to put in here what they have given me. So they said the triangular brace has one side that's 9 meters long. The angle opposite the 9 meter side is 70 degrees. Well, you don't know which one that is, but that's this angle right here. It'll be part of your picture, 70 degrees, the whole angle. And then this is 9 meters from here to here, because that's the side opposite. Then it went on to say that angle C is 31 degrees. And we need to find that height of the brace. So they're not asking you to solve the triangle in this one. They're asking me to find this height right here. I can't use Pythagoras' theorem because I don't know how long this is. I know the whole thing is 9, but I don't know how much this piece is. This altitude of a triangle, which is the height of the brace, does not cut this into two pieces, nor does it cut the angle into two pieces. So all I know is the whole angle is 70, but I don't know what that part of the angle is. I do have one angle here, which usually with trig, we can deal with one angle so long as we have one side. But I don't have any side lengths to this triangle here. All I have is this side length, and this triangle is not a right triangle. So I need one side length here, here, or here in order to be able to use any kind of SOHCAHTOA, sine, cosine, or tangent, in this little triangle here, because if I knew just this side or this side, then I could use sine, cosine, or tangent to find this. So let's use law of sines, because I've got two angles and one side. So I want to know what that side is, because this angle is across from this side, which, I mean, I could choose to find this side and use that angle, or I could, because this side would belong to that triangle, and so does that height. Or I could use this angle here, and I can find this side. For the whole big triangle, this side is across from angle B. So if I'm going to figure out what angle B is here in a minute. If I use law of sines, I can find out what that side is. And then once I have that side and that angle, then I can use sine, cosine, or tangent. So I think that's what I'm going to do. So step 1, use the sum angle theorem. So I'm going to shorten that a little bit. So we're going to take 180 degrees and subtract from that the sum of these two angles. 70 plus 31 equals, well, 70 and 31 are 101. Subtracting from there gives me 79 degrees. So the measure of angle B is equal to 79 degrees. So that's one piece that I'm going to need. So I'm going to put that 79 degrees here. So then part 2, I want to find side B, little b, which is this side right here. It's across from angle B. I know the entire angle A and the side opposite it. So I'm going to use law of sines. Sine of A over side A equals sine of B over side B. Plug in what you know. Sine of A, so A is 70 degrees, divided by the length of side A, which is 9, equals sine of B. We now know that B is 79 degrees, divided by the length of side B. That's what I don't know. So then we're going to cross multiply and solve. So I have B times sine of 70 degrees equals 9 times sine of 79 degrees. you want to find B, so I want to get B by itself. So divide both sides by sine of 70. And so B is equal to 9 times. So I'm going to find the sine of 79 degrees. So here's 79. Sine is 96, or 9816. 0.9816 divided by the sine of 70. So here's 70.9397. So use your handy dandy calculator. I've got 9. Oops, can't even see that. Nope. So I've got 9 times 0.9816. That equals, so then divide by 0.9397. So B is approximately equal to, I'm going to round it 2 places, 9.40, and then I'm in meters. So this is part 2. So I'm going to go ahead and write that in my picture. So B is equal to 9.40 meters. So now look at this triangle right here. On this triangle, I happen to know that this is my degree of reference. I'm trying to find H, which is side opposite, and I know this side, which is the hypotenuse. The 9 only belongs to the big triangle. So opposite and a hypotenuse, OH is so sumopipy, so sine. So in step 3, I'm going to use TOA to find H. And we're using sine because we have opposite and hypotenuse. So I have the sine, I know my degrees is 31, equals opposite H over the hypotenuse, which is 9.40 or just 9.4. Since your unknown is in your fraction, turn this into a proportion and cross multiply and solve. So you get H is equal to 9.40 times the sine of 31 degrees. So we've got 9.40 times, let's find the sine of 31 degrees, 0.5150. And so H is approximately equal to we have 9.4 times 0.5150. So we get 4 point, and I'm going to round that to 2 places. So it's 4.84, and then that's in meters. So that's my third and final piece. So therefore, the question said, what is the height of the brace? So therefore, the height of the brace is about, because we do estimate, 4.84 meters. Oops, and we can't see that.